Next is our CPU socket, people. And how are we doing out there? I know you have a lot of information thrown at you all at one time. So just remember that a lot of this that we're doing in this chapter, we're going to repeat in later chapters. So you will hear it a little slower. You will hear it a little more detailed. All right. Moving on. CPU sockets. When you buy the motherboard, you just predicted what CPUs you can have and cannot have. There's no changing the CPU socket. It is integrated, soldered into the motherboard. So the CPU socket can be in two forms. We'll see them in the CPU section. PGA, not golf, pen grid array, or LGA, land grid array. Basically means one uses pens, one uses pads for the CPU to sit into. So LGA is usually Intel CPUs, and PGAs are AMD. All right. Memory slots. Memory can be a major bottleneck of your computer, of your computer's performance, in other words. So everything that gets processed has to be put in the memory, and then the memory sends the instruction over to the CPU. That is how everything in your computer system works. It goes from the hard drive, loads into memory, memory sends it over the front side bus to the CPU, and the CPU crunches and executes that instruction. So think about it. If we don't have enough memory, then we're not going to be able to take advantage of the speed of the processor. So we need that holding tank in the middle, which is our RAM, to be abundant. This is also helping you know where you need to spend your money. So random access memory, the principal storage space for computer data and program instructions, storage space. It's volatile. So that means it'll lose data when there is no power to it. Believe it or not, the RAM that we use in our computers has to be refreshed 1,000 times per second to keep the information consistent in it. So if you, and this, you guys, this has happened to everybody. If we don't have auto-saved on our Word docs already on, where it's saving the information periodically, if that's not on, and we're working on a document and we didn't hit save, power goes out, there's no battery, we're on a desktop, boom, so did that document and went out the door. Because memory temporarily holds the instruction as long as there's power to it. So we'll keep that in mind. So there's volatile memory, and that is packaged into DIMMs, dual inline memory modules, as we see here. And then the amount of DIMM slots predicts the total amount of memory that one motherboard can support. Chipset, we talked about briefly a second ago, and memory architecture. So chipset and memory architecture is what we're going to discuss now. And like I said, a chipset provides communication between different components by implementing various controls. Stop, go. If you're following on that, if you're on that road, you can go 100 miles an hour. If you're on this road, you can only go 15. So speeds on the lanes on the motherboard has a lot of detailed information it controls. So system memory, input, output, HDMI, all of them, they're all controlled through the chipset. Integrated video. This means your video card that's built on your motherboard, sound and network cards, all on your motherboard are going to be handled by that chipset. At the top here, Snapdragon, this is a chipset that's built into mobile devices. And then you can see a regular chipset, which mostly can be Intel. And that's going to be either located on the motherboard or inside the processor itself. Some chipsets are integrated in the processor. You have to check all documentation on this. But they are not upgradable. So when you buy a computer and you get the motherboard, the chipset you're stuck with it. So make sure you pay attention to what type of chipset, what you're good, what you're bad when you're making your decision on motherboards. All right. The next thing we'll have on a motherboard is a simple CMOS battery. CMOS, complementary metal oxide semiconductor. That's a really nerdy thing you don't need to remember. And RTC battery, real-time clock. Now, in the older days, when I was a kid, back in the 90s, the battery itself would actually help retain the motherboard's program, which we call the BIOS, the firmware. It would help retain that because that used to be on a volatile memory chip, meaning that if there's no power to the chip, the program for the motherboard would literally disappear. So that is no longer the case. And the reason why I'm telling you that is because on the exam, they like to throw that at you and make sure you understand now, today's computers and motherboards, the last 20 years, we don't use the CMOS battery for anything but the date and time. So the date and time is kept when you shut off the computer and pull the power supply out of the back. It's kept by the CMOS battery. And that's the only thing the CMOS battery is good for at this particular state and technology, is to keep the time and date running. 5 to 10 years, these batteries are set to work and last. All right, so we're not going to have to replace them usually because we're ready to replace the laptop or desktop before that time. Now, if I pick up a motherboard and we look at the back of it, that is going to be called, all these fine little lines you see, they're going to be called buses and traces. Now, there's no way with a human eye you can tell the difference between a bus and a trace, especially when you're looking at the pathways, the thousands of them on the back of a motherboard. The one thing you can determine is all them wires go to they terminate at one device. What is that device? What is that device? Excuse me. Correct. That device is the CPU, the central processing unit, right? Everything terminates to that CPU because that's where all the information needs to be calculated and crunched. So it carries electrical signals along the motherboard, but along with electrical signals, it carries data, power, which we just said, and timing. What components can go at what time and what speeds. So the bus connection between components on the motherboard and peripheral devices attached to the computer. It can also be when you put in a card in your PCIe slots. Okay? So buses and traces are the pathways you see all over the motherboard. And there are the three things again. Data, power, timing signals, and synchronization. That's what all these pathways are used for. Now, there's also internal and external buses. Your internal buses, your local bus, is the internal bus that links components directly to the processor, resulting in the highest possible data speeds as required by components such as video display. So if we're looking at this RAM and we see the CPU, one of the things is called the front side bus. The front side bus is your fastest bus on the board because it's taking your RAM. We said all instructions go from your hard drive into your RAM, and then they get processed to the CPU. While this is your front side bus, and this allows for quick access from the memory to the CPU. And remember, the chipset controls this. There's also buses to the CPU from slower devices. These could be from network cards, USB, things of that nature. We can plug them in expansion cards, or they can be on a port. And that's going to go through slower local buses, but they're all trafficking back to the CPU. And here are expansion slots that we briefly discussed earlier. They are connection slots on the motherboard in which the adapter cards can be installed to extend the range of functions the computer can perform. So, here is your by 1, by 4, by 8, and by 16. You can see that this is how the new PCIe equates to the speeds in which each expansion bus can go. Here are by 16, you can see, again, having that little flipper on it. And then these right here are the older style PCI, which is for backwards compatibility and is not something you're going to be using in the present or the future. A riser card. This is another type of expansion slot. This is really odd. Like if you have a slimline case and you have a card that is higher than what the case allows for, then you're going to put a expansion slot riser card in it. And that card is going to literally plop in vertically, but in a low profile, and allow the card to fit this way so that the long card can fit into the computer. This is common in servers. Server racks have a very low profile. And then you have these big cards you're trying to fit into them. They physically cannot fit directly vertically into the slot. So what do? We get that riser card and we plug them in sideways to get the functionality. All right, now that I gave sign languages there, we are moving on. On the motherboard, there is a system clock. The system clock helps produce bus speeds. So the system clock is the computer's timing mechanism that synchronizes the operations of all parts of the computer and provides basic timing signals for the CPU. What does that mean, Anton? Well, look at this metrodome down here. The metrodome is something that people that play pianos and music, you probably already know about. It goes, what is it doing? It's keeping the tempo. That's what the system clock does inside of the motherboard. It keeps the tempo. It makes sure that everybody's running at a consistent time for synchronization and things to work. So the system clock speeds themselves are measured in either megahertz, 1 million cycles per second, 1 million on and offs per second, or gigahertz, 1 billion cycles per second. And just think of, again, computers are pretty dumb. They only know two things, on and off, 0 and 1, like a light switch. So if we have a 1 gigahertz processor, it is turning the light switch off and on 1 billion times in 1 second. And that's how we get these incredible results out of computer systems. All right, so the clock generator initiates time signals. The clock multiplier adjusts its time signals for different buses because depending on the pathway or the bus that you're using, some buses head down roads where the speed limit is at 55, and you can go 55 miles an hour. Other buses or pathways on the motherboard, the bus is on a residential community and it's going to only run 25 miles an hour. So it makes sure that these things can run at different times and different speeds. Think of the system clock as acts like a drummer in a band. So the drummer in the band will definitely keep that tempo. Boom, chicka, chicka, boom, chicka, chicka, boom, right? When you're starting to sing, you can't go ahead of the drummer. You can't slow down behind the drummer or the sound, and that song is going to be pretty much kaput. So think of it as a drummer in a band synchronizing everybody else in harmony to work together.